Hey everyone, welcome to ITGS 431, week 3. I'm Dr. Phelan, and this week we're going to be talking mostly about digital twins, but also some video game design career stuff. So, I wanted to start out just by addressing what is a digital twin. This is something you'll read more in depth, but a lot of people, there's a lot of confusion between digital twins and models and simulations. And part of that confusion comes from the fact that people within industry don't even use those terms the same way. So there is quite a bit of overlap between the terms and inconsistencies. But for our purposes, a digital twin, actually, let's start with a model. So, a model is typically a 3D representation of something in the real world, but it can also be just a mathematical representation of that thing that we can put some inputs into and get some outputs of. If that is a continuous process where we are watching as these things change over time, then you might consider that a simulation where as the model is running, as the simulation is running, we can adjust the parameters and see different results. A digital twin, however, is a dynamic virtual copy. So, the thing that differentiates a digital twin from a model or a simulation is that rather than dealing with static data or one time inputs, a digital twin will usually incorporate real time data updates to reflect the current reality of its real world counterpart. So you may have telemetry data, usage data, temperature data, all kinds of different things that are impacting the representation of the digital twin. And then you can then run simulations based off of that real time data. And there are a bunch of different use cases for it. And this week, there are three that I've listed, and you'll read two of those. So the first is about smart cities, the second is about hospital design, and the third is for self-driving cars. So you look at all three of those, and or you look at two of the three of those rather, and get a better understanding of how digital twins are different from simulations and models. The other thing I want to point out here is again, there is a lot of inconsistency between how people use these. The real kind of differentiating feature is that digital twins use real time data compared to a simulation that's using predefined data or something that you kind of manually adjust as you run the simulation. Both of them allow you to do interactions and predictive analysis, but digital twins typically they're designed at the model layer to be as realistic as possible, whereas simulations tend to have simple statistical models or simplified representations. Digital twins tend to be much more complex. All right, so that is the majority of what I want to say about digital twins. I don't want to just copy all this over, but make sure you read through all of this information and especially read the digital twin facts, and you can see more information about how those are used. And there are a bunch of different case studies. If you find that these three that I've listed aren't as interesting to you, feel free to read one or two of the others instead. So, since our course is focused on simulation and learning, I want to talk about careers in 3D design. So, a lot of times when we think about a 3D design career, we think about building three-dimensional models that are used in games or simulations. And that is definitely one aspect of 3D design. However, there are a bunch of other things that can branch off of that. And I'm going to caution you in the reading about these national average salaries. These are very simplistic. The national average takes into account the fact that a lot of these people who are reporting their salaries are self employed or are working in part of what is commonly referred to as the gig economy. And so if you're working for a big game design firm as a graphic designer or a video game designer, the salaries can be much higher than 30,000 a year. So aside from video game design, we also have graphic design, which is more focused on product rendering. We have illustration, we have graphic design concepts, color theory, things like that. Um, 3D printing technicians, a lot of studios will use 3D printing for prototyping, modeling, even for special effects work. So sometimes we have specialized people who are involved in that process. And then we talked about the 3D designer, the person who is materializing the concepts into three-dimensional models. But we also have animators and riggers who will then take those models and animate them. And a lot of that work is done in the video game industry, but also in the movie industry for special effects studios. Architects use a lot of the same concepts that we use in video game design for doing architectural work and layouts and mocks. Professors for teaching this stuff. Art director is another kind of managerial position within the realm of 3D design that will oversee a team of artists, 3D designers, graphic artists, things like that. And so an art director incorporates, they have this whole vision of the project and they're manipulating a lot of moving pieces. And then we also have web developers, and it's a bit of a stretch here the way that they're talking about it, but there's a lot of web development work involved in online gaming and things like that. So if you're interested in that, it's a nice horizontal career path to explore. All right, so again, this week, make sure you are fully versed on what 3D, on what digital twins are, because that's a big part of gaming and simulation these days, especially in the world of VR and AR work. And then read a couple of these case studies. Assignments, you will talk about digital twins, and then you will evaluate two of the case studies and talk about that as a separate assignment. Okay. As always, if you have questions, just reach out on Slack or via email.